So let's continue, my dear friends. In previous session, we have completed arithmetic mean. So in this session, we'll try to complete partition values, mode, and if time permits, we'll complete that GM, HM, everything related to central tendency. Okay. So if you remember, my dear friends, I said you what is the meaning of central tendency. In central tendency, we are trying to locate one observation which helps you to judge the data. That one observation is called a central tendency value. Next, I said you, we have three types of central tendencies values: median, partition values, and mode. And I said you, mean is algebraic measure, and I hope you understood now what is an algebraic measure. Next, partition values and mode, they are called as positional measures. 4 partition values we have, and 3 means we have. Mode is single, like this. Next, comparative analysis we have started. In that, first we have looked into arithmetic mean. So first I said you, what is the definition of arithmetic mean? Arithmetic mean refers to sum of observations by number of observations. Next I said you 3 different formulas: individual data, summation of x by n; discrete data, summation of x into x by summation of f; continuous data, summation of m into f by summation of f. Next I said you how to calculate combined or grouped or pooled arithmetic mean. Will be n1 x1 bar plus n2 x2 bar divided by n1 plus n2. Next I said you weighted formula. Summation of w into x divided by summation of w, that is weights. When all observations are of not equal importance, there you give weight and then you will calculate arithmetic mean, that is weighted arithmetic mean. Next I said you one observation is 0, one observation is negative, doesn't impact our data much because we are dealing with arithmetic mean. That impact will be on GM and HM. Next, I said you that if all the weights are same, simple arithmetic mean and weighted arithmetic mean will be same. Next. So all these concepts we have done. Next, arithmetic mean, I said you, it gives importance to highest observations and it is affected by extreme values. Next, I said you where you use, where you don't use GM and HM. Next, if all observations are same, AM is same. Next, if only 2 observations are there, A plus B by 2 will give be your arithmetic mean. Next, in progressions, in arithmetic progression, mid value will be your arithmetic mean. That we have seen one example as well. Next is when we are discussing other points in arithmetic mean. I said you the sum of differences from arithmetic mean is equals to 0. That is sum of deviations from arithmetic mean equals to 0. Take any numbers in number system, calculate arithmetic mean, do observations minus arithmetic mean, answer will always be equals to 0. Point number 2 is pending, we'll discuss in this session. Next, I said you the formula for correct arithmetic mean, old arithmetic mean into old observations minus incorrect value plus correct value by new observations. I hope you have completed that homework sum before this session. Make sure that you will complete those homework sums so that you will have more clear clarity on the data, what we are reading. Next, I said you arithmetic mean is simple, easy to calculate, is an algebraic measure, it is rigidly defined, suppressed measure, and stable measure, right? Next. And I said you arithmetic mean is highly affected by extreme observations. Next, I said you few cases where arithmetic mean of first and natural numbers and square, n cube, n even numbers, and n odd numbers. Now, let us see an example of these deviation formulas. Then let's go to geometric mean and harmonic. Okay. Yeah, we have seen change of scale and change of origin concept as well. I said your entire central tendency is affected by scale and origin. Scale means multiplication, division. Origin means addition or subtraction. This is very important, my dear friends. Especially when I do dispersion, correlation, and regression. There you will see how the scale and origin impacts our entire data. Now see this deviation formula. I'll take one example. For continuous data and discrete data, you need not do deviation formula. Just formulas are there. I'm explaining that formula. It's not that important for exam perspective. Never they have asked it till now. Okay, once or twice in 2010 or 9, I hope they have asked. Now I'm having 5 observations. 5, 7, 13, 15, and 20. These are the 5 observations what we need. Observations. 5, 7, 13, 15, and 20. Now, basically, what we do for calculating arithmetic mean, we do sum of observations divided by number of observations. Now, what I do is that any one value, I assume it as assumed mean. I'll assume it as mean. Let us assume 13 as assumed mean. Okay. What I said, you sum of deviations from arithmetic mean must always be equal to 0, right? Let us see whether my assumed mean is correct or not. If my assumed mean is correct, the sum of deviations from arithmetic mean will be 0. If it is not correct, it will not be equal to 0. Let's do 5 minus 13, we have minus 8. 7 minus 13, we have minus 6. 0. 15 minus 13, we have 2. 20 minus 13, we have 7. Now 7 plus 2 minus 6 minus 8. Is it equal to 0? No, it's not equal to 0. It's equals to 5. But if your mean is correct, it will be equal to 0. Since your mean is not correct, it is equals to 5. Okay. Now what I'll do, I'll apply one formula. This is called as deviation from assumed mean. Okay. Arithmetic mean will be equals to assumed mean plus deviations from assumed mean divided by number of observations. Okay. Assumed mean is 13 plus minus 5 divided by 5. So 13 minus 1, which is equals to 12. So this is my arithmetic mean. A plus deviations by number of deviations. A plus deviation by number of deviation. It is discrete data or continuous data. Formula will be A plus summation of f into d divided by summation of f. Now, sir, why I have to do this much nonsense? What is the sum of these things? 5 plus 7 plus 13 plus 15 plus 20. It is 60. Instead, can I do 60 divided by 5? Again, it is same 12. And why I should read deviations? Don't read deviations. There is no use. In olden days, there was no calculator. That's the reason they used to do this. Now, calculator is there. You can do this. Calculator. No need to do this deviation formulas. Only one thing you remember. Here, A will be mid value. Because sometimes in deviation, MCQs it asks, in deviation formula, what does A represents? A represents mid value. Okay. Next. Now, what is the definition of arithmetic mean, my dear friends? Sum of observations divided by number of observations. In the same way, let's get to geometric mean. Now, 1 minute. So let's continue. Now, arithmetic mean, I said your definition is sum of observations divided by number of observations. Yes, sir. Then what is this geometric mean? Geometric mean is nth root of product of observations. Nth root of product of observations. Nth root of product of observations is your geometric mean. Sir, nth root of product of observations? Yes. Like say if you see individual data, I'm having observations x1, x2, x3, so on. I'm telling nth root of product x1 into x2 into x3, so on till xn. Like say for example, I'm having 4 observations. 4, 8, 16, 32. So what will be the geometric mean? Geometric mean will be 4 under root 4 into 8 into 16 into 32. Let's see. 4 into 8 into 16 into 32. It will be 11.313. Okay, how will you do 4 under root? You will write the value 4 into 8 into 16 into 32 equal to, then you will press the root symbol 2 times. Okay. See, this is not that important for examination, but just students' curiosity to know. If it is 2 under root a, you'll do a root. Okay. If it is 4 under root a, you'll do a symbol root 2 times. Like say for example, I am having 4 under root 625. We all know 4 under root 625 is 4, 5 power 4 is 5. Then calculate how will you do? 625 press root symbol 2 times. 625 root you will get 5. Okay. Next. 8 under root a under root 3 times. Okay. Any other number is there means you will apply this whole lengthy formula. Okay. I made a calculator video. There you can get this. However, that's not important for the examination. Not in a single time it was asked in the examination. Because in the bracket already value will be given. I said you know student curiosity to know that. So you can I'll just refer the video once. You'll understand that concept. So I hope 2 root a, 4 root a and 8 root a is clear. Just root symbol 1 time and 2 root symbol 2 times, 4 root symbol 3 times, 8 root. You will get the answer. Next. Now this is under individual data. Now discrete data. In discrete data, what we have frequencies, right? Now if x1 is repeated 3 times, how will we write? x1 into x1 into x1, which is nothing but x1 power 3. That is I will do x1 power frequency. x1 power f1 into x2 power f2 into x3 power f3, so on till xn power fn whole power 1 by summation of f. Now, like say for example, observations, frequency, 10, 20, 30, 40, 2, 3, 1, 2. Okay, sum of frequency 8. So it will be 10 square into 20 cube into 30 power 1 into 40 square whole power 1 by 8. So 10 into 10 into 20 into 20 into 20 into 30 into 40 into 40. Root symbol 3 times. 1, 2, 3. 21.03. Okay. Now in continuous data, what we'll have? Instead of this x1, x2, x3, so on till xn, we have m1, m2, m3, so on till mn. Okay. For continuous data, we have m1 power f1 into m2 power f2 into m3 power f3, so on till mn power fn whole power 1 by summation of. Okay. So I hope individual data, discrete data, and continuous data formulas are clear. Let's see one question on this continuous data, which is from ICI material itself. Yes, only one question is there in ICI material on continuous data for geometric. Discrete data, they didn't give any question itself. Or why to leave that one question? Let's do it also. Let's do it and let's wind it up. Let me open this ICI material 1 minute. So I hope there was no issue till here. You were in a position to understand all these things. Now, measures of sample tendency. Measures of sample tendency. No, he gave example on discrete data. He didn't give example on continuous data. Fine. He also like it's not relevant for us much. Okay. Now, let us come back to our discussion. So, what is the definition? Nth root of product of observations is called a geometric mean. Individual data formula we have seen, discrete data formula we have seen, continuous data formula we have seen. Now, my dear friends, for a combined and group or pooled geometric mean, the formula is anti-log summation of log x by n. Now, there are no questions which have been asked in the examination till now. But what you need to remember is you need to remember these two formulas. Because what he asked in the examination is he directly ask you to write the formula. That 4 options will be given, you need to select the correct formula. However, it was asked 2 times in the examination till now. Okay, solving he never asked. Okay, because the anti-log formula is there, yeah, weighted formula is there, but the combined formula is not there in ICI method as well. But once he asked, so I've included it here. Okay, just you need to remember them. You need not solve any sums on this combined and weighted. Next, if one observation is 0, obviously geometric mean will be 0 because you are multiplying. When you are multiplying something with 0, obviously it will be 0. If one observation is negative, what is the root of negative? Undefined, sir. Like he'll ask you in the exam, he'll ask you one question. Company records both profits, losses. Profits it is recording in positive figure, losses it is recording in negative figure. Which of the following measure cannot be calculated? Geometric mean cannot be calculated. Okay. It records both profit and losses. Unfortunately, geometric mean cannot be calculated. Next. Next, importance. Geometric mean gives importance to all observations. See, arithmetic mean gives importance to highest observations. Geometric mean all observations. Harmonic mean lowest observations. So highest, all, low. That's how you remember. Highest, all, and low. Next, since it gives importance to all observations, basically, if we use them in index numbers, rates, ratios, and percentage, whenever there's a constant increase or decrease. Now, since it gives importance to all observations, we need to use them in bank and money calculations. In money calculation, you can't say that this is important, that is unimportant. Everything is important. That's the reason this rates, ratios, and percentages, they relate to money. Okay, that's the reason there we use geometric mean. Once he asked in the examination, he gave 3%, 6%, and 12%. He asked you to calculate average. See here, percentages are given. When percentages are given, you can't use arithmetic mean. You have to use geometric mean. So you will do 3 under root 3 into 6 into 12. 3 under root 216, which is equals to 6. Because 6 cube is 216. So 3 under root 216 is 6%. Or else you can say, sir, it is in geometric progression. So mid value is geometric mean. That's also fine. Okay. In order to, in index numbers, when we do index numbers, there I'll tell you why geometric mean is used. Next to average, rates, ratios, and percentages. Whenever there is a constant increase and decrease. There is one question which I'll share in homework. You can see that question. It says, from the past 10 years, there is a constant increase in population. What is the average population? In this case, we'll be using geometry. From past 10 years, there's a constant decrease in population. What measure will be used to calculate average? Geometry. Only one question is there in ICI method. That's the question what I said you just now. That this question I'll share you. These 2 questions I'll share in the homework session. Once try to solve them. Okay. After the class, I'll share them. If all observations are constant, GM, HM is constant. If only 2 observations are given, what will be geometric mean? Root of 2 observations, A into B. Next, in geometric progression, mid value will be your geometric mean. Next. Other points in GM. Geometric mean of X into Y will be geometric mean of XY. Okay, see, I want to show you. Geometric mean of XY will be geometric mean of X into geometric mean of Y. Geometric mean of X by Y will be geometric mean of X whole divided by geometric mean of Y. Right? Like say for example, in examination, he'll ask you like this. This is one question in your ICI method, even exercise also you'll find this question. He'll tell geometric mean of X is 10. Geometric mean of Y is 15. He'll ask you what is the geometric mean of X into Y. It'll simply be 10 into 15, 150. Simple. In options, he'll give you log 10, log 15, log 150, and he'll give you 150. You should go ahead and you have to select 150. Okay. So I hope the concept of GM is clear. Yes, sir. The concept is clear. It's quite simple. Geometric mean. There's nothing special in this geometric mean. See, arithmetic mean is little lengthy. GMA HM, they are not lengthy. They are very simple. Okay. And all the questions in your ICM method also I covered. There's no question which is pending. Other than he's asking what is GM of 8, 24, 40. 8 into 24 into 40, 3 under root you can do. There's nothing much difficulty in that. Okay. One question is then ICM material. I'll cover that also. Why to keep it pending. Geometric mean of 8, 24 and 40. How will you calculate? 3 under root 8 into 24 into 40. 3 under root 8 into 24. Can I write it as 8 into 3? 40, can I write it as 8 into 5? Yes. So 3, 8 is repeated 3 times. So I'll take it outside. 3 into 5, 15. So geometric mean of 8, 24 and 40 is 8, 3 under root 15. See, you need not use a calculator trick. Okay. Because if options are given, he'll give like this directly. He will not complicate in the examination, especially these days. Okay. So everything with respect to geometric mean is covered, my dear friends. AM is over. Yeah, GM is also over. Now let's get to harmonic, my favorite. Then we'll be done with mean. So that we'll start with mode first and then we'll go to partition values. Okay. Yes, sir. Now let's run. Harmonic mean. You know, these days there's a reel which is getting viral so much. Cheen tabaka tam tam. Cheen pataka tam tam. There is a reel. Yes, now I saw the reel. Cheen tabaka dum dum. I hope you have heard to this reel. Let's listen once again. Nice reel. So harmonic mean is also like that only. Cheen tabaka tam tam. So basically harmonic mean is reciprocal of arithmetic mean of reciprocal of observations. What? Reciprocal of arithmetic mean of reciprocal of observations. Like say for example, I am having 3 observations A, B, C. Reciprocal of observations. 1 by A, 1 by B, 1 by C. Arithmetic mean sum of observations divided by number of observations. Reciprocal 3 divided by 1 by A plus 1 by B plus 1 by C. Say na ulta ka palta. First ulta, fir palta. Okay, that's your harmonic mean. Ulta ka palta. So 3 divided by 1 by A plus 1 by B plus 1 by C. First I have done reciprocal. Then I did arithmetic mean. Then I did reciprocal of the same. So that's the reason reciprocal of arithmetic mean of reciprocal of observations. So individual data, what is the formula? So individual data formula will be n divided by 1 by x1 plus 1 by x2 plus 1 by x3 so on till 1 by xn. So discrete data. What is 1 by x1 plus 1 by x1 plus 1 by x1? 3 by x. So frequency is there, you do frequency by x1. Summation of f whole divided by f1 by x1 plus f2 by x2 plus f3 by x3, so on till fn by xn. Now continuous data, instead of x, we'll have mid value. Summation of f whole divided by f1 by m1 plus f2 by m2, so on till fn by mn. Like say for example, I am having 2, 3, 5. How will you calculate harmonic mean of 2, 3, 5? You will do 3 divided by 1 by 2 plus 1 by 3 plus 1 by 4. Now, listen carefully. How will you do this? You have to do it in the calculator. How will you do it in the calculator? First, target the denominator. 1 by 2 and plus 1 by 3 and plus 1 by 5 and plus. Then MRC. See, nowhere I pressed equal to. 1 by 2 and plus 1 by 3 and plus 1 by 5 and plus. Then MRC. 3 divided by MRC equals to. Numerator divided by MRC equals to. You will get it as 2.90. Okay. Once try this, you will get it. I'll give you one more example. There is no issue. I guess I have written here also. Yeah, see here. I have written here. 1 by x1 m plus 1 by x2 m plus 1 by x3 m plus so on. Then directly do n divided by MRC equals to. You will get the answer. Like I'm having 4, 5, 10, 8, and 16. Can you calculate harmonic mean for this? How will you do? I'll just show you do it in a calculator. 1 divided by 5 m plus 1 divided by 10 m plus 1 divided by 8 m plus 1 divided by 16 m plus, then 3 divided by MR, sorry, 4 divided by MRC equals to 1 divided by 5 m plus 1 divided by 10 m plus 1 divided by 8 m plus 1 divided by 16 m plus 4 divided by MRC equals to. I'm getting 8.20 something. Once check whether you are getting same or not. No need to press MRC after this one. Not required. Directly if you do also, you will get the answer. But be careful, if your calculator is remembering the memory, erase the memory. How will you erase the memory? Press MRC 2 times and then do this. So see once you both are getting. So I hope you understood how to calculate that. One question. I'm asking what is harmonic mean of 1, 1 by 2, 1 by 3, 1 by 4, so on till 1 by n. So what is the harmonic mean of this? How will we calculate? Simple. How will you calculate harmonic mean? N divided by 1 by 1 plus 1 by half plus 1 by 1 by 3 plus 1 by 1 by 4, so on till 1 by 1 by. Because what is the formula? N divided by 1 by a plus 1 by b plus 1 by c, so on, right? So n divided by 1. What is 1 divided by 1 by 2? It will become 2. 2 comes to numerator. 3 comes to numerator. 4 comes to numerator. So on till n. N divided by 1 plus 2 plus 3 plus 4, so on till n. Sum of first and natural numbers. N into n plus 1 by 2. And then cancel. 2 comes to the numerator. 2 divided by 2 plus 1. See first what you have done. You have taken the progression. Then n divided by a harmonic mean formula you applied. 2 came to numerator, 3 came to numerator, 4 came to numerator. Then I have applied sum of n numbers formula. N divided by n into n plus 1 by 2. n cancel, 2 divided by n plus 1 is answer. Okay. Next. Like we had combined arithmetic mean, we have combined harmonic mean also. Sometimes he'll ask which of the following can be combined. Option A AM, option B GM, option C HM, option C all of this, or option D all of this. Your answer should be option D all of this. Okay. Combined harmonic mean will be N1 plus N2 divided by N1 by HM1 plus N2 by HM. That is discrete data formula itself. See, sometimes in examination, if you don't remember combined formula, no, apply discrete data formula, answer will be same. All these are developed from discrete data itself. Like say for example, I am having N1 is equals to 75, N2 is equals to 65. No. HM1 is 75, HM2 is 65. N1 is given as 15, N2 is given as 13. He's asking combined HM. Same again. 15 plus 13 whole divided by 15 by 75 plus 13 by 65. As usual, first do the denominator. 15 divided by 75 m plus. Next 13 divided by 65 m plus. So you'll have 28 divided by 0.4. And we have 70. Okay. So I hope it's fine how to calculate combined HM. So if you see, we have seen 3 basic formulas. We have seen combined HM formulas. Now, where we'll be using this harmonic mean? The main place where you will be using this harmonic mean is to average speed, distance, and time. Like say for example, I'm telling a person is going from A to B at 500 km per hour. Is returning back from B to A at 700 km per hour. I'm asking what is the average speed. In this case, what you will do, you will use harmonic mean. So it will be harmonic mean will be 2 divided by 1 by 500 plus 1 by 700. Let's do it in a calculator. 1 by 500 plus 1 by 700 m plus 2 divided by MRC equals to 1 divided by 500 m plus 1 divided by 700 m plus 2 divided by MRC equals to 583.33 kilometers per. Okay, so this would be his average speed. Now try this sum and tell me the answer. Example: a person is going from A to B, B to C, C to D, and D to A. A to B he is going at 600 kilometers per hour. B to C he is going at 550 kilometers per hour. C to A is going at 300 kilometers per hour. And D to A is going at 900 kilometers per hour. Can you tell me what is the average speed? Simple. Let's try to calculate it. Calculate and tell me. 4 observations are there: 600, 550, 300, and 900. Perfect, Vaishnavi. One more answer. Perfect. So answer is 504.45. So 4 divided by 1 by 600 plus 1 by 500, so plus 1 by 550 plus 1 by 300 plus 1 by 900. Okay, so I hope the point is clear how to calculate the harmonic mean for individual data. Next, let's look into harmonic mean now. So the same, first reciprocal of arithmetic mean of reciprocal of observations. Then these three formulas we have done. Next I said you combined or group. Next, weighted arithmetic mean. Again he'll ask, see, weighted formula is somewhat again similar to discrete data itself. In discrete data you have frequency, here you have weights. Again, this is not important over here. What is important is only this one is important. Okay. Now, if any observation is 0, what do you think HM will be? What is something by 0? Obviously, sir, something by 0 is undefined. How can you calculate something by 0? HM will be undefined. If one observation is negative, can you calculate HM? Obviously, sir, we can calculate HM because HM, how will you calculate? Can I do 1 divided by minus 5? Obviously, I can do. Can't I do reciprocal of negative numbers? Yes, sir, you can do reciprocal of negative numbers. Nobody will stop you. So HM is possible to calculate. There is no issue. Next, as said you, this will give importance to highest, all, and lowest. Average of speed, time, and distance. This one. There's again one question is ICM like this. One value is constant in several places. There will be one kid. What he does is that he will take 100 rupees. With this 100 rupees, he'll go to 10 different markets and he'll see how many XP he'll get. So at the end, what he'll do average of all these things. What nonsense is. He's no time pass. He's very free, that guy. For time pass, he's doing all these things. So simply one value is constant in several places, then you will be using harmonic mean. Next question is then I'll share you in the homework session. Once see that, you will understand how funny the question is. Next, harmonic progression, though we don't have, mid value will be your harmonic mean. Next, if two observations are given, what will be the harmonic? Like I'm having two observations A comma B. What will be the harmonic? 2 divided by 1 by A plus 1 by B. So 2 divided by LCM will be A plus B by AB. Right? LCM. This goes to numerator. 2AB by A plus B. 2AB by A plus B. Next. Relationship between AM, GM and HM. If all observations are same, AM, GM, HM, all the three will remain. In case of positive unequal observations, like say for example, I am having 9 comma 16. What is the arithmetic mean of 9 and 16? It's 12.5. What is geometric mean? It's 12. What is harmonic mean? 2AB, 2 into 9 into 16 divided by 25. 11.5. So can you see what is greater in all these things? 12.5, 12 and 11.52. So in case of positive unequal observations, AM is greater than GM, GM is greater than HM. Next, AM into HM will be equals to GM square. Like see here itself. Yeah, see. Just now I said you AM is A plus B by 2. HM is 2AB by A plus B. Can I cancel A plus B, 2? What is left? AB is left. AB, can I write it as root AB whole square? Yes, sir. What is root AB? Geometric mean. geometric mean square. Okay. So AM into HM will be equals to geometric mean square. Like he'll tell you AM is 5, HM is 20. Then what is GM? I'm telling AM is 5, HM is 20. Can you tell me what is GM? Think and tell what is GM. AM is 5, HM is 20. So AM into HM will be 100. GM square is equals to 100. GM is equals to root of 100, which is equals to 10. Okay. Next. Now, see this fourth one. It's an important one. Sometimes what happens, he'll give you AM and GM, and he'll ask you the two numbers. Okay, from where this AM and GM he got. Like say for example, I'm telling AM is equals to 6.5, GM is equals to 6. What you can do is you can do option verification, or else you can apply this formula. AM 6.5 plus or minus root of AM square 6.5 whole square minus GM square. So 6.5 plus or minus root of 6.5 whole square is 42.25 minus 36. 6.5 plus or minus root of 6.25. So it will be 6.5 plus or minus 2.5. Plus or minus 2.5. That will be 6.5 plus 2.5. 6.5 minus 2.5. 6.5 plus 2.5. It will be 9. 6.5 minus 2.5 will be 4. So those two numbers are 9, 4. Numbers are 9, 4. AM is 6.5. GM is 6. Okay, so I hope the point is clear. All the 4 points, relation between AM, GM, and HM. Other points in GM. Next. Yeah. So with this, we complete first part of central tendency. How many central tendency values we have? 3. We have 3 central tendency values. First, mean. Next, partition values. Third, mode. So first one, mean is complete. Now what we'll do, let's go to mode first, and then we will do partition values. Okay. What is this mode? Not the mode what will take turn, it's mode. And it's not mode also, it's mode. Mode. Now, what is this mode? Mode refers to most repeated observations or observation with highest frequency. Okay, most repeated observations or observations with highest frequency. Like say for example, 5, 7, 7, 7, 9, 9, 9, 9, 9,999. What is the observation? What is the most repeated observation here? 7 is most repeated observation. So mode is 7. Okay. I'm having 5, 3, 3, 3, 4, 4, 4, 7, 7. What is the most repeated observation? 3, comma. So it can be either unimodal, 1 mode, bimodal, 2 modes, trimodal, 3 modes, multimodal, more than 3 modes. Simply the most repeated observation is called as mode. Now, where you will use this mode, you will use it in case of fashion items and zoology. fashion items, so many repetitions will be there, right? So many repetitions. So there you will be using. And even in case of zoology, you will use. I don't know why they use in zoology, but they say in zoology. Next, individual data, most repeated observation. Discrete data, observation with highest frequency. Like I am having observations and frequency. Observations are 10, 20, 30, 40. Frequency is 5, 7, 9, 5. What is the observation with highest frequency? 30 is the observation with highest frequency. So mode is 30. Okay. So I hope the concept of mode is clear. Now, let's do continuous data. We'll learn it with the help of an example. Then after that, you can solve one question on continuous data. 1 minute. So sorry for the disturbance. Let's continue. Now, let us understand it with one example. Continuous data. It's a little lengthy formula, I understand. But yeah, little important. In ABC, are categorized as category B. Example. I am having observations. I am having frequency. 350 to 369, 370 to 389, 390 to 409, 410 to 429, 430 to 449, 450 to 469. Frequency 15, 27, 31, 19, 13, 6. Now it's an inclusive data, right? We need to convert it to exclusive data, but no need to convert the entire data. It will be time-based to convert the entire data. Now, what is the model class? Only that I will convert. Now, first step, what you need to do is that you need to find out model class. Sir, what is the model class? Where frequency is highest. Where the frequency is highest? Here the frequency is highest. Okay. Next. Now this is termed as F1, F0, F2. F1 is frequency of model class. F0 preceding frequency. F2 succeeding frequency. Then you will apply one lengthy formula. It's not lengthy, it's simple. L plus F1 minus F0 divided by 2 F1 minus F0 minus F2 into class interval. What is L here? No, not this one. This is inclusive. Convert to exclusive. I said your entire data I will not convert, only this one I will convert. For the lower value, 389.5. Higher value, 409.5. Okay. So first, lower class bound, 389.5. F1 minus F0, 31 minus 27. I hope it is 4. 2F1, 2 into 31, 62. Minus 27 minus 9. What is the class interval here? 20. How will you calculate the class interval? Class interval will be upper class boundary minus lower class. So 389.5 plus 4 into 20 is 80. By 62 minus 27 minus 9, 60. So 80 divided by 60. So 389.5 plus 5. 394.5. Okay. So first locate the model class. What is the model class? Model class is that class which has highest frequency. You can ask me one question. Sir, what if two classes are having highest frequency? That is not the answer. You'll learn it in your BCom. That's a very complicated process. You'll learn it in your BCom. Next step. First, you will locate that observation which has highest frequency. Fine. Perfect. Next, we will apply the formula L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into class interval. L is lower class boundary. F1 frequency of model class, F0 preceding frequency, F2 succeeding frequency. Ci class interval, how will you calculate upper class boundary minus lower class? Fine. Perfect. Yes, sir. Perfect. Now, you people solve one question. I'll give you 5 minutes time. Observations. Frequency. 0 to 20. 20 to 40. 40 to 60. 60 to 80. 80 to 100. 5. 18. X. 12. 5. Find X if mode is 44. Mode he is telling 44. Mode is 44 means obviously this will be your model class. Okay. So this will be F1, F0, F2. Okay. Sir, you are solving the whole question. No, let me solve. Next question. In homework session, I'll give you one question. Okay. So that when you are doing homework, there I'll give a little more complicated. Okay. Here X is missing. How will you calculate mode? L plus F1 minus F0 divided by 2F1 minus F0 minus F2 into class interval. Right? Mode, how much is mode here? 44. L 40. F1 minus F0. X minus 18 divided by 2x minus 18 minus 12. Obviously, class interval is 20. 60 minus 40. Send 40 here. 44 minus 40 is 4. So x minus 18 divided by 2x minus 30 into 20. Let's do cross multiplication. 8x. What is 4 into 30? 120. Is to 20x minus 180. Not 180, sir. 360, sorry. Okay. Take 360 here. Take 8x here. So 360 minus 120 is equals to 20x minus 8x. What is 360 minus 120? 240 is equals to 12x. 240 divided by 12, I hope it is equals to 20. Okay. So what is the value of x? X value is 20. Okay. These are the maximum type of sums what you can find on mode. Okay. So I hope, my dear friends, all the concepts are clear. Concepts related to mean, the concepts related to mode. It's not much difficult, mean and mode. Okay. Now what we'll do, we'll start partition values. We'll do only individual data. I'll not eat too much of your brain. I'll eat only to the extent of individual data. In tomorrow's session, I'll complete partition values and dispersion. 2 dispersion topics will come. So in the after tomorrow, dispersion chapter will going to be completed altogether. So central tendency and dispersion, very lengthy chapter, and 1 class we take for effects. It's not more than 1, maximum 2 sessions. Okay. Now, partition values. Again, mode is a positional measure. I need not tell that. Partition values. What are these partition values? These partition values are something which divide the data into many parts. They break the data into many parts. That's the reason we call them as partition values. 4 partition values we have: median, quartile, decile, and percentile. Median divides the data into 2 parts. Quartiles, 4 parts. deciles, 10 parts, percentiles, 100 parts. Simple. Now, median, quartile, decile, and percentile. So first what you will do, you will arrange the whole data into ascending order. Okay. Median, let it be median, quartile, decile, or percentile. First you will go ahead and you will arrange the data in ascending order. After arranging the data in ascending order, what you will do? If it is median, you will take average of middle observation. If it is median, average of middle observation, or you will take mid value. Let me give an example. See, partition values are simple. What you are doing is you are dividing the data into parts. That's it. Sir, why you will divide the data into parts? See, there is no use of this in statistics. Only median is used. That's not, none of the partition values are used. Like say for example, I'm having 5, 10, 15, 20, 26. I'm asking what is the median? Is it even data or odd data? Odd data, sir. How can you say 5 values are there? So it's an odd data. You will take the mid value. So median is mid value 15. Okay. Next. I'm having data somewhat like this. I'm having data as 7, 10, 15, 19, 26, 31. Is it even data or odd data? 1, 2, 3, 4, 5, 6. It's an even data. How can you say that? Because there are 6 values. Average of middle 2 values. 15 plus 19 whole divided by 15 plus 19 divided by 70. So I hope it's clear how to calculate median. We are doing for individual data. Today, let's do only individual data. Okay, tomorrow we'll do discrete and continuous. If it is even data, you will take average of middle 2 values. This odd data will take mid value. Okay. Next. This is with respect to median. Now let's do quartiles, deciles, and percentiles. Now in quartiles and deciles and percentiles, first step remains same. You arrange the data in ascending order. Okay. After that, you will apply one formula. Quartiles divides the data into 4 parts, right? J into n plus 1 by 4. Deciles divides the data into 10 parts, right? So J into n plus 1 by 10. Percentile divides the data into 100 parts, right? So J into n plus 1 by 10. My dear friends, remember, there are only 3 quartiles. 3 quartiles divides the data into 4 parts. Like I am having a rod. I want to make it into 4 parts. How will you make? 1, 2, 3. Make 3 cuts. It's enough. Those 3 cuts will divide the data into 4 parts. Okay. I hope the concept is fine. See, n refers to number of observations. Then what the hell is J? J refers to the value what we require. I want quartile 2, J is 2. I want quartile 1, J is 1. I want quartile 3, J is 3. I want decile 7, J is 7. I want decile 3, J is 3. I want percentile 40, J is 40. I want percentile 75, J is 75. Okay. I hope the concept is fine. Simple. Next. Now, these formulas, will they give answer? Unfortunately, no. These formulas will not give the answer. Sir, okay, sir. If these formulas will not give the answer, what will give the answer? These formulas will just give the location. They will not give you the answer. The location you need to identify to get the answer. क्या बात कर रहे हो, sir? I'll take you an example. See here. I'm having 15, 10, 20, 25, 18, 11, 9, and 12. This is the data what I have. First is asking you to calculate quartile 1 and decile 3. These 2 things is asking to calculate. Let's calculate. First, is it in ascending order? No, sir. From which angle it looks for you ascending order? Let us arrange it ascending order. 10, 11, 10 kata, 11 kata, 12, 9, next 15, 18, 20, 20, 18, 20, 20. 1, 2, 3, 4, 5, 6, 7. Okay. First, I'll calculate quartile 1. First step is completed. Second step, j into n plus 1 by 4. 1 into 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1 by 4. 1 into 9 by 4. 2.25. My dear friends, note this, the 2.25 is not the answer. Okay. 2.25 is the location. It's a location. 2.25 is the observation. You need to identify this location. How will you identify, sir? Second observation plus 0.25 into third minus second. Second observation 10 plus 0.25 into third minus second. So 10 plus 0.25 into 1. 10.25. This is the answer. Sir, how did you get this? Simple. I'm having 3.76. How will you get? Third observation plus 0.76 into fourth minus third. I have 11.36. 11th observation plus 0.36 into 12th minus 11th. Okay. D3 I'll calculate. D3. First step done. Second step, j into n plus 1 by 10. 3 into 8 plus 1 by 10. 2.7th observation. It's not an answer, just a location. So second observation, 2.7 means it lies between 2 and 3 plus 0.7 into third minus second. What is second observation? 10 plus 0.7 into 11 minus 10. 10 plus 0.7, 10.7. So I hope it's fine, everybody, how to calculate. Please calculate this and tell me the answer. Then we'll wind up the session. Example 15, 18, 10, 20, 23, 28, 12, 16. I want you to calculate quartile 1 and percentile 70. Not in ascending order, first arrange it in ascending. So let's solve this. First, let's arrange it in ascending order. 10, 12, 16, 10, 12, 15, 16, 18, 20, 23, 28. So first quartile 1. First step is done. Second step, arrange it in ascending. Sorry, first step ascending order done. Next, j into n plus 1 by 4. J by 1 quartile 1. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 1 by 4. Now, 9 by 4. What is 9 by 4? Again, said same 2.25 itself. Is it the answer? No. Second observation plus 0.25 into third minus second. So 12 plus 0.25 into 15 minus 12. So 12 plus 0.75. Because 15 minus 12 is 3. 3 into 0.25 is 0.7. So 12.7. 75. Okay. Next, let's look into P70. First step we have done. Second step, G into N plus 1 by 100. So 70 into 9 plus 1 by 100. Sorry, 8 plus 1 by 100. Because 8 observations are there. 1, 2, 3, 4, 5, 6, 7, 8. 70 into 9 divided by 100. 6.3. Is the answer? No, it's just a location. It's not an answer. So 6th observation plus 0.3 into 7th minus 6th. What is the 6th one? 20 plus 0.3 into 23 minus 20. It's 20 plus 0.9, which is equals to 20.9. Okay. So if you have done any mistake, just see where you have done a mistake and rectify that. Okay, he's telling 2.225. It means it lies between 2 and 3. 6.3 means it lies in between 6 and 7. Okay. So I hope that's fine. So that's all regarding partition values. Discrete and continuous, we'll do it in the next class. And we'll close this chapter discussion. I'll send few more sums today that you can practice it before attending tomorrow's session or before attending the next session.